Today we're going to dive into sedimentary rocks, and these are a fascinating part of geology because this really tells a story of where the rocks came from, the source, where they've been transported, or even how they've been transported to come up with all kinds of interesting formations and shapes and colors. So let's get right into it. We're going to start with where these sedimentary rocks come from in the first place, and so then we have to talk about the sediments themselves. So anytime we start weathering a rock, it could be igneous like the one pictured here, it could be metamorphic or even some other sedimentary rock, we start to get little fragments which we call sediments. Now we can also look at some of the organic material that is replaced with mineral fluids, and this becomes something like we see with fossils or any other sort of organic material that is replaced in some way with calcite, with silica, or some other mineral. So usually involved in this process is some kind of chemistry where you're having an exchange of minerals for other materials. In other words, we want to solidify and cement our rock into something a little more permanent. So what are sediments? These are loose particles. They can be inorganic or they can be organic material. If they're inorganic, maybe it's rock. It could be smooth or fragmented pieces of rock. They could be rounded boulders or pebbles. It could be dust fragments. The size is hugely variable. And in the future, we may even consider plastic as an inorganic type of material. We also have organic material, as we alluded to. So shells and bones and some of these organic pieces of material that come from living organisms can be turned into fossils. So any material that is really broken down into some form, transported, and then deposited by gravity is something that we would consider a sediment, and it usually gets deposited horizontally and eventually solidified. Now we can't get into sediments without talking a little bit about erosion and weathering, because this is ultimately where most of our sediments come from, the erosion and cold weathering of some kind of original material. Let's start with our definition of what we mean by erosion and weathering. Erosion involves the movement or transport of some of this rocky material and particles by wind, by water, glaciers, or even just gravity, by falling down a hill. Weathering, on the other hand, involves the breakup of rock by a physical, chemical, or biological process in place. In other words, there's no transportation or movement of the material in weathering. Okay, so these are the two differences, and we're going to start with looking at some of the weathering because that's the source. That's where our sediments ultimately come from. So let's start with physical weathering. We have several types, and these are rocks that are broken up by the elements, and this is a very mechanical or physical process, as the name implies. First is the frost wedging. Rocks will naturally split as water percolates through cracks and fissures and then freezes in the winter. The reason it splits is because when ice forms, it expands and forces the cracks to be larger, ultimately resulting in cracks and the breakup of the rocks. You see a lot of the effects of frost wedging in the Sierra, where you have the jagged peaks, and at the foot of the mountains you see a big jumbled pile of broken rock. Next we have unloading or exfoliation. These are where slabs of rock actually peel away due to reduced pressure. So this reduced pressure comes from a couple of sources. One is, think about the rocks that have been formed at depth. When they come to the surface, that pressure is no longer there, and so they're able to slightly expand. And this can cause fractures in those outermost layers of those granitic intrusions. The other possibility is that you have a load on the rocks due to glaciers or some other material, and once that erodes away or melts, suddenly that rock is able to expand with the lowered pressure. So either of these mechanisms can produce exfoliation. And the best example are some of the rocks in the Sierra where the granite looks like it's a bunch of onion skin layers.
Here's a nice example of exfoliation in some of these granitic rocks. There's a relatively horizontal, well, slightly dipping direction of fractures that enable the rocks to peel away.
Thermal expansion is another form of weathering where big temperature swings from day to night will result in the expansion and contraction of mineral grains in a rock, similar to the expansion cracks in a sidewalk. Now, these temperature swings occur mostly in desert environments. Over time, these cracks will deepen and collect sand and soil, which allows vegetation to grow and contribute to further breaking down the rock through those deepening roots that work their way into spaces between the mineral grains. Now, sandstone is not the only one. We see it in granite and any other rock in an arid environment. You can sometimes see split rocks with nice clean fractures, as well as broken up material surrounding it. Next, we have hydraulic action, and this is where on coastal environments you get waves crashing into the rocks. And when there is a little bit of a fracture or a crack, the incoming wave compresses the air that's in there and creates an extremely high pressure, and it fractures the rock at microscopic levels. And slowly over time, you can start to see the development of large fissures and eventually a sea cave or a blowhole and other features on the coast. Next, let's talk about chemical weathering. And this is, as the name implies, a chemical process. Water is probably one of our greatest agents of weathering. Over time, water will erode or dissolve a mountain. So when rocks are in contact with water, several things can happen. Depending on the composition of those rocks, you can get an alteration of the internal structure by water. So water molecules slowly surround those crystalline rocks, and they slowly create little ions and dissolve that rock. So you have a decomposition eventually of the rock through these chemical reactions. And let's get into several ways in which this decomposition happens. First off, we have dissolution, or sometimes it's just called solution chemistry or solution weathering, where the chemistry of the fluids reacts with the rock to weaken that material. And eventually, because it's so weak, it just sort of falls off. So an example would be carbonic acid that is produced by the CO2 in the atmosphere that combines with water to create a very weak acid. But over time, this acid will dissolve limestone, and it's this reaction that creates caves in limestone. You can see this kind of weathering on rocks, even on the surface, where they have a very sharp, angular sort of weathering pattern. Next, we have hydrolysis, and this is pretty similar to dissolution, but carbonic acid acts in place to break down the rock into clay. This is particularly true with volcanic ash that gets embedded in soils and is broken down by hydrolysis. In other rocks that may contain joints or very parallel fracture sets, you might get water that seeps down those fractures and weathers through hydrolysis, softening the less resistant minerals and thereby creating very rounded corners. Next, we have oxidation. Again, this is dependent on the chemistry of the original rock. If it has iron in it, water will oxidize it. In other words, it rusts it. It produces iron oxide. And we often see this in desert rocks. You will see very large red streaks or dark streaks on the rocks, and these are caused by this oxidation. Now, some of that might be produced by bacteria, but nevertheless, there's an oxidation process. Finally, we have biological weathering, and this is where tree roots and lichen and animals can actually physically get in there and start to break down the rocks. So tree roots have their roots that work their way into the little fractures, and they start to force apart some of the crystals at a microscopic level. They might also be absorbing water that is percolating into the rock and eventually some soil particles. And so a combination of the material that's in the soil as well as water will produce chemical reactions as well as the physical process of breaking it apart by the roots. Lichen is another example that can attach to rocky surfaces. You see lichen in all kinds of environments, from very arid desert environments to the rich foresty areas as well as coastal areas where there's a lot of sea spray and seawater in the air. Animals can also burrow into the ground or into fractures in the rock and scrape them. You also have marine animals that literally scrape the rocks to gather algae that's on the surface. So all of these processes act to break down the rock in a physical sort of way. On a final note, it's somewhat rare that you get a single process acting alone. An example would be the alteration you see in geothermal areas, like this one here in Lassen Peak National Park. Here we have steam and temperature working to break down the mud, combined with some of the water that's circulating in the system to produce very muddy, very liquid, very altered rock at the surface. In another episode, we're going to take a look at erosion, which works with weathering to break down mountains and fill the valleys.